Okay, in this lecture I just want to recap few of the things that we have studied till now. Number one, we have studied about the centroid. It is the point of intersection of the medians, right? It divides the median, or we can say it divides each of the medians in the ratio 2:1, where the bigger part is on the vertex side, right? And the coordinates of the centroid G are x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, where what is x1 y1? x1 y1 is the coordinate of one of the vertices. Similarly, x2 y2 and x3 y3. Let us say x2 y2 are the coordinates of this point and x3 y3 are coordinates of this point. What I want to highlight here is that I can rewrite this x1 plus x2 plus x3 like this. If I write this x1 plus x2 plus x3, x1 plus x2 by 2 plus x2 plus x3 by 2 plus x3 plus x1 by 2, then this expression here and this expression here are the same expressions, right? I have not changed anything, because if you open this or if you simplify this, you will get x1 by 2 from here and x1 by 2 from here. When you add these, you will get x1. Similarly for x2 and similarly for x3. So what I can do here is I can rewrite this formula like this: x1 plus x2 by 2 plus x2 plus x3 by 2 plus x3 plus x1 by 2 whole divided by 3. And similarly for the y coordinate I can do the same. Now what are these? X1 plus x2 by 2, x2 plus x3 by 2 and x3 plus x1 by 2. These are nothing but the x coordinates of the midpoints of the sides of the triangle, right? What I mean to say here is, let us say if I want to find the coordinates of this midpoint f, okay, because this is the median which is given, okay, and f is the midpoint of AB. So what I'll do here is I'll just add x1 and x2 and divide by 2 and I'll get the x coordinate. Similarly y1 plus y2 by 2, I'll get the y coordinate. So this is the x coordinate of the midpoint of one of the sides. Similarly, this is another midpoint, this is another midpoint. So if the midpoints of sides are given and you are supposed to find the centroid, you do not require to find the vertices. You can directly find the centroid, because the centroid of the inner triangle made by the midpoints will be the same as of the outer triangle. This is one of the points that I wanted to highlight. And now in center we have studied that it is the point of intersection of internal bisectors of the angles, and it is also the center of the circle touching all sides of a triangle. We have discussed about it in great details. What I want to highlight here is that side length opposite this vertex A is small a, okay, this is small a. And what is this x1? X1 is the coordinate of this capital A. X1 is the x coordinate of this vertex. So when I'm considering this side length here, I'll multiply it with the x coordinate of the opposite vertex. So that is why AX1. And I'll multiply side length B, which is side length B, this one is side length B, with the x coordinate of this here B. So when I write B, I'll multiply it with x2. Now this seems very simple, this sounds very simple, but when it comes to the solving of questions, you will find this information very useful. Okay, all right, so this we have already studied, this fact, right? Circumcenter, we already know, that is point of concurrency of the perpendicular bisectors. It is point of concurrency of perpendicular bisector, and it is equidistant from the three vertices of the triangle, right? We have discussed about it already. Orthocenter is point of intersection of altitudes. Now I want you to note these three things: that in an equilateral triangle the centroid, incenter, orthocenter and circumcenter all coincide at one point. For example, if you want to find the centroid or incenter, orthocenter or circumcenter, all are the same point. Okay, all these points coincide or are the same. Okay, so if you are given some coordinates, let us say if you are given some coordinates of the vertices, and you are supposed to find, let us say, the orthocenter. In class 10th you cannot directly you do not know the vertices of orthocenter, although I have told you about the vertices, but you will not be supposed to learn that formula in class 10 at least. So you just need to check if the three vertices form an equilateral triangle. Okay, if by any chance this triangle is equilateral and you are supposed to find the orthocenter, then rather than finding orthocenter, you can directly find the centroid, which is simpler to find, right? And that will also be the orthocenter. I hope you have understood what I am trying to say here. In an isosceles triangle, the centroid, incenter, orthocenter and circumcenter are collinear. Okay, anyways, centroid, orthocenter and circumcenter are collinear, right? But in an isosceles triangle, incenter also falls on the line joining centroid, orthocenter and circumcenter. Now in a right angled triangle, the circumcenter is the midpoint of hypotenuse and orthocenter is a point where right angle is formed. For example, let us say I take a right angle triangle, then this angle is 90 degrees, right? So if I draw a circumcenter, that is passing through the three vertices, now this angle is 90 degrees, right? This angle is 90 degrees, so this angle has to be the angle in a semicircle. So this has to be the diameter, the hypotenuse of the triangle, right triangle that we have taken has to be the diameter. So what will be the center of this circle? It should be the midpoint of this hypotenuse. Okay, so what I have said here is I have taken a right angle triangle, I drew a circle passing through the three vertices. Now you know from the basic geometry that this hypotenuse is the diameter because this angle is 90 degrees. So the midpoint of the diameter will be the center. What is the midpoint here? This is the midpoint of the hypotenuse, so it is the circumcenter. Now orthocenter is the point where the right angle is formed, so this is the orthocenter in this triangle. What is orthocenter? It is the point of intersection of altitude. So if I drop a perpendicular from here to this side and from this vertex to this side, right, and if I drop this perpendicular here, right, so what is the point of intersection of these three lines? This is the point of intersection. So in a right triangle, the vertex at which the right angle is formed is the orthocenter. So if you are given, let us say, three vertices, okay, and you are supposed to find the orthocenter and you are told that it is a right angled triangle, right? You are given a right angle triangle. It is already given in the question that it is a right angle triangle and you are given three vertices and you are supposed to find the orthocenter, right? And you have to choose from the given options. So one thing should be very clear to your mind from the very beginning, that it is a right angle triangle, right? So the orthocenter will be the vertex at which the 90 degrees angle is formed. So it will be a vertex. So the answer will be from these three options which are already given. Answer will be one of the vertices, right? So if there is only one of the answers that satisfies it, or you can say if out of the given options there is only one option which gives you the vertex, one of the vertices of the given triangle, then that will be your orthocenter. Without even solving further, you can say that this is my orthocenter. All right. Another thing that we discussed was that circumcenter, centroid and orthocenter of a triangle are collinear and the line on which they lie is known as Euler's line. Also, G divides HO in the ratio 2:1. This is also something that we have already discussed. Okay.